In this video, we'll talk about atomic structure and the source of charge. To understand where the phenomenon of electric charge comes from, the basic structure of matter needs to be discussed. All matter is made up of atoms, which are made up of protons, neutrons, and electrons. Each atom contains a central nucleus that is composed of protons and neutrons. We call them nucleons. Electrons move around the nucleus in the empty space of the atom. Electrons are fundamental particles. They have no underlying structure. Protons and neutrons are not fundamental particles. They are made up of quarks, which are fundamental particles. J.J. Thomson found a particle that had a very low mass for its charge. In fact, its mass per charge was 1,800 times less than the previously lowest amount measured for a particle. Before this work, physicists were speculating that the hydrogen atom was the smallest fundamental particle. This led Thomson to propose that this negatively charged particle was new, and he called them corpuscles. The name electron was taken from George John Stoney's work in 1874 and proposed again by George F. Fitzgerald, and the name stuck. Furthermore, since the electron was so much lighter than the hydrogen atom, it was concluded that it must be part of the atom. The electron was discovered by J.J. Thomson in 1897, and in a series of experiments between 1909 and 1913, Robert Millikan and his graduate student, Harvey Fletcher, established the value of the charge E on an electron. Millikan and Fletcher's work and subsequent experiments have established the value of E as being equal to 1.602 times 10 to the minus 19 coulombs. It has also been demonstrated that this is the smallest value of charge, with the exception of quarks, which we will cover shortly. And all larger charges are an integral multiple of this value. Because small amounts of charge can generate large amounts of force, charge is often measured in millicoulombs, microcoulombs, or nanocoulombs. Remember the metric prefixes for this unit. Further research showed that the electron has a mass of 9.11 times 10 to the negative 31 kilograms. So the charge of an electron is 1.6 times 10 to the minus 19 coulombs, and the mass of the electron is 9.11 times 10 to the negative 31 kilograms. While finding the charge on an electron, it was discovered that the charge on an object was an integral multiple of the electron charge. Thus, you can have a charge of 3.2 times 10 to the minus 19 coulombs on an object, but you can't have a charge of 3.0 times 10 to the minus 19 coulombs. The charge on any object is always an integer value multiplied by 1.6 times 10 to the minus 19 coulombs. So let's go ahead and practice some of the things we just learned. Which of these could be the charge on an object? Remember, E is equal to 1.6 times 10 to the minus 19 coulombs. Go ahead and pause the video now and see if you can choose the correct answer. Okay, so let's check and see if you have the right answer. The correct answer is C. C is the only number divisible by 1.6 times 10 to the minus 19 coulombs. Which of these could be the charge on an object? Again, using E equals 1.6 times 10 to the minus 19 coulombs. Go ahead and pause the video now. Okay, so let's see if you've chosen the correct answer. The correct answer again is C. The electron was discovered by A. J.J. Thomson, B. Robert Millikan, C. Harvey Fletcher, D. Ernest Rutherford. Go ahead and select your answer now. Okay, so let's see if you chose the correct answer. The correct answer was A. J.J. Thomson was the first person to discover the electron. The electron charge was first measured accurately by A. J.J. Thomson, B. Robert Millikan and Harvey Fletcher, C. Niels Bohr and Paul Dirac, D. Ernest Rutherford. Go ahead and select your answer now. Okay, did you choose B? Because that is the correct answer. Charge on nucleons. Protons and electrons have equal and opposite charge. By convention, as we discussed from Ben Franklin's work on charged materials, electrons have a negative charge and protons have a positive charge. This is the origin of charges on material objects. Neutrons have no charge. They are neutral. Atoms are electrically neutral, not because they contain no charge, but because they have equal numbers of protons and electrons. Their total charge adds up to 0. If an atom gains electrons, it has a net negative charge and is called a negative ion. If it loses electrons, then it has a positive charge and it's called a positive ion. Like energy and momentum, charge is neither created nor destroyed. It is conserved. Opposite charges attract and like charges repel. As a result, negatively charged electrons are attracted to positive nuclei. Despite the great mass difference, the charge on an electron is exactly equal in magnitude to the charge on a proton, and its magnitude is denoted by the letter E. An electron is said to have a charge of negative E, and a proton is said to have a charge of plus E, or positive E. What the atom doesn't look like. This is not what an atom looks like. If an atom was magnified so that the nucleus was the size of a baseball, the atom would have a radius of 4 kilometers. The electrons would be approximately the size of the period at the end of the sentence. Atoms are almost all empty space. Since everything, including us, is made up of atoms, that means everything, including us, is mostly empty space. Here's a more realistic look at a helium atom. The nucleus is buried deep within the atom and is 1 million times smaller than the atom. The 2 protons and 2 neutrons are shown in red and purple, and the width of the nucleus is 1 × 10⁻⁷ nanometers. The diagram shows a magnified view of the nucleus. It fits within the darker circle. What is the significance of the dark circle surrounded by the lighter shades of gray and pink? You know that helium has 2 electrons, yet they're not shown on this picture. That's because we don't know exactly where those electrons are. We only have a probability of where they might be. The darker the shade means that it is more probable that the electrons are found within that shape. For more information, please refer to the Quantum Physics and Atomic Modeling chapter of the Algebra-Based Physics course on the New Jersey website. It has been shown that electric charges move between objects. Based on this picture of the atom, which of the constituents of the atom look like they could move? Would it be the neutrons and protons buried deep within the atom, or the electrons? The electrons are the particles that will move between atoms. They are not bound together as tightly as the protons and the neutrons. The electrons are fundamental particles. At the moment, physicists have not found any further structure within the electron. However, the same cannot be said for the neutron and the protons. Neutrons and protons are actually made up of elementary particles called quarks. Mary Gell-Mann, along with George Zweig, proposed the existence of these particles to help explain the many different types of particles that make up matter. Mary coined the term by taking it from James Joyce's novel Finnegan's Wake, an interesting intersection of physics and art. There are 6 types or flavors of quarks that describe their properties, and they are further classified according to their color. Not a real color, just a handy inventory management tool. They are up, down, strange, charmed, top, and bottom. And they have charges that are either plus or minus 2/3 E or plus or minus 1/3 E. Before this work in the 1960s, it was thought that the smallest particle charge on a particle was E, the charge of an electron or a proton. A neutron to the left is composed of an up quark and 2 down quarks. So you can see that if you take the charges and add them up together, you end up with 1/3 plus 2/3, which will end up giving you your total charge of nothing. The study of quarks is called quantum chromodynamics and is way beyond this course. If you want to learn more about it, don't ask me. Quantum chromodynamics is something that is studied by theoretical nuclear physicists, like my professor, Dr. Radushkin. But one final interesting point, the quark is subject to all 4 fundamental forces: electricity and magnetism, gravity, the strong, and also the weak nuclear forces. Which of the following are fundamental particles? Select 2. Okay, let's see if you have the right answers. You should have chosen electrons and quarks. Remember, protons and neutrons are made up of quarks, so they are not considered fundamental particles. An atom in a normal non-ionic state has no charge. This is due to the fact that the atoms, A, have only neutrons, B, have no protons or electrons, C, have equal numbers of protons and electrons, D, have an equal number of protons and neutrons. Go ahead and select your answer now. Okay, so hopefully you chose C as the correct answer. What object moves freely within the entire atom? Is it an electron, a neutron, a proton, or the nucleus? Go ahead and select your answer now. Hopefully you chose A, the electron. An atom is composed of A, a central nucleus that is surrounded by neutrons, B, an even distribution of electrons and protons in a spherical shape, C, a central nucleus surrounded by electrons, and D, a central nucleus containing protons and electrons. Go ahead and select your answer now. Okay, so let's go ahead and see if you chose the correct answer. You should have chosen C, the central nucleus surrounded by electrons. What are neutrons and protons composed of? A, nothing. They are fundamental particles. B, corpuscles. C, quarks. D, electrons. Go ahead and pause the video if you need to. The correct answer is C. They are composed of quarks. Actually, it's not letting me select it, but here you go. C. There we go. C. Okay, in the next video, we're going to cover solids.